Hello everyone. In today's video, we'll understand the data preparation phase to model the data. So, how to partition the data first? Partitioning data refers to splitting the data sets into subsets, usually training, validation, and test sets to evaluate the performance of the model. The first is the training set, which is used to train the model. For example, if we have a data set, we'll split it into 70, 20, and 10, in which the 70% of data sets will use for the training of the model, the 20% will be the testing of the model, and the 10% will be the evaluation or the cross validation of the model. So, in the right hand side, we have used the sklearn, which is the scikit-learn, in which we are using the train test split function and pandas library. We have the data, which is having the dictionary of with key feature one, two, and the target variable. We have converted into the data frame, and by the using of train test split data sets, we have split it into the X training data, which is the variable X train. X test will use for the testing purpose, and similar with the Y train and Y test. Then we have how to balance the training data sets. Like balancing is required when the target variable classes are imbalanced, which can bias the model towards the majority classes. So it is required for us to balance the data, or we are having the structured data. So the imbalancing will be reduced and the model predictiveness or the output will be fair. So first is oversampling. It increases the size of the minority classes by duplication. And basically oversampling, which means the model tries to cover every parameter it has, then it is only available to that particular local data set. But when it gets exposed to the training data set, to the real world data set, it will not perform well. Then we have sometimes we have undersampling, in which it reduces the size of the majority classes, in which we have very few parameters or the few features. The model does not even perform well in the training data set, as well as will not perform in the test data sets. Then we have SMOTE, which is the synthetic minority oversampling technique. It generates synthetic samples for the minority classes. And in the right hand side, we have a snippet of code. You can use it in your IDEs as well. Then we have to build the card decision tree, which stands for classification and regression trees. Decision tree that can handle both classification and regression tasks. So basically, decision tree is something which we use for the predictions. For example, if I want to play football or not today, so I'll check with some of the parameters. For example, how much is weather is it is. It maybe it can be sunny, windy, rainy. Then humidity, that it is humid, very humid temperature or not a humid temperature. Maybe it is a weekend or weekday, so I have to work or I have to work not. So regarding these parameters, a decision tree will provide me should I play football today or not. So yes, the tree splits the sets on the features of the maximize the reduction and impurity. In decision tree also we use the Guinea index techniques for the result purposes. And in the right hand side, you can see the snippet of the code. You can also test this in your IDE for the better understanding. Then we have the build C 5.0 decision tree, which is the extension of the C 4.5 decision tree algorithm, which is based on the classification. It offers faster training and reduced memory usage. In Python, C5 can be implemented using libraries like scikit-learn. Again, we have the snippet here. Then we can build a random forest, in which it also helps in the building of decision tree, but we can make more than one decision tree and connect them together for the better understanding. And this is the summary of techniques we have just saw. Like for the partition, we use a library sklearn. The function is the train test split. Then for balancing data, we use the SMOTE. Then we have seen the card decision tree, which is stands for classification and regression trees, in which the criteria will be the Guinea index here. Then we have saw the C 5.0 decision tree. Then again here the criteria will be the entropy. The entropy should be always less for the better results. Then we have saw the random forest. Again, it is from the sklearn library. Then we are using the here random forest classifier function with the n estimator. So thank you. I hope you guys have understand that what is the basic of model training and what techniques and functions and libraries we can use for the training of model. Thank you.